Okay, for today's notes, we are going to be applying systems of equation methods to solving word problems. So remember, the graphing method is easy to see. It's also a really easy way to help us analyze and be able to understand what is happening. So again, if it is more about seeing what's going on, then the graphing method is going to be our best option. The substitution method is the best option when we have one equation that has a coefficient of x or y whose value is 1. As long as we can rewrite one of the equations so that x or y is isolated and we're left with no fractions or no decimals, then the substitution method is really pretty simple. The third and final way is the elimination method. And remember, that is best to use if all the coefficients are greater than 1. Okay, so we've got ours, but I want you to make sure you understand that every strategy will produce the same solution xy. Whether I choose to graph the problem, whether I choose to use the substitution method, whether I choose to use the elimination method. If solved correctly, no matter what method I use, I'm going to get the same solution. So ultimately, it is a personal preference. What method do you like to use? Do you feel the most comfortable with? And then that would be a method that would be a good one to go with. All right, let's go ahead and try solving 3 word problems. So the first one we're going to try to solve using the graphing method. So it says Craig and Tori are having a friendly competition to see who can get the most signatures on a petition that they have to get the junior highs to run a final exam week like the high school does. So Craig has collected 30 signatures. Tori has collected 40. Craig is averaging 2 new signatures per minute. Tori is managing to, I think it's supposed to say collect, not college, to collect an average of 1 signature per minute. Assuming the trend continues, when will the tie happen? Okay, so let's go ahead. We've said X is number of minutes and Y is number of signatures. So let's go ahead and first let's just talk about Craig. So Craig has 30 signatures and Craig is averaging 2 signatures per minute. So I can go ahead and write down Craig as y equals 2x plus 30. Okay, so then let's go ahead and let's write down Tori. So Tori has 40 signatures, but Tori is only getting 1 per minute. So let's go ahead and write down Tori. Y equals x plus 40. So now we're going to graph that system. So first I'm going to start at 30. And a slope of 2 on this graph would be the same as up 20 over 10. So I'm going to go up 10, 20 over 10. Up 10, 20 over 10. Up 10, 20 over 10. And then from there, I've run out of room. I'm going to graph, and I'm going to say C for Craig. Okay, now I'm going to do Tori. Tori starts at 40, and a slope of 1 would be the same as up 10 over 10, and I just found it. Up 10 over 10, up 10 over 10, up 10 over 10. And I get my line, and there is Tori. So then the final question, how many more minutes will it take for them to break the tie? It's going to take 10 minutes because it just wanted to know the time. So I look at that, and then I just come down here and see that it's going to take 10 minutes. Okay, so there's an example of how I can solve using the graphing method. All right, for the next 2, instead of the graphing method, we're going to choose between the substitution and the elimination, whichever one seems like the best option once we get our system written. So at a clothing store, t-shirts cost $10 and sweatpants cost $15. If Andy spends $220 and buys 16 items, how many did he buy of each? Okay, so the first thing we have to do is we have to decide what are we going to make sweatshirts and what are we going to make the sweatpants and the t-shirts. So I'm going to make X be the t-shirt. And I'm going to make y be the sweatpant. All right, so first I can talk about, well, we're going to buy 16 items. So I can get an equation for the number of items. All my t-shirts plus all my sweatshirts is going to total up to 16 items. And then I can write one about money. T-shirts are 10, sweatpants are 15, the total was $220. So now I'm going to use that information. A t-shirt was 10, so 10x. A sweatpant was 15, so 15y. Equals my grand total of 220. Okay, as soon as Mrs. Stroll notices that the items equation has coefficients of 1, I personally am going to go ahead and do the substitution method. So for step 1, I am just going to rewrite the equation isolating one of the two variables. I'm going to isolate x. So x is going to equal 16 minus y. Okay. For step 2, I am going to substitute that into the second equation. So I'm going to do 10 times plus 15y equals 220. So now I'm going to go ahead and substitute in that 16 minus y. So that is going to give me 160 minus 10y plus 15y equals 220. So that is going to give me 160 plus 5y equals 220. Subtract 160. I get 60, divide by 5, I get 12. So right now, I know that I bought 12 sweatpants. Okay. So now for step 3, I'm going to plug that into the first equation. So I am going to say x equals 16 minus, and now I'm plugging in that 12 for y. So that means x equals 4. So now I know I had 4 t-shirts and 12 sweatpants. I have found the solution. And I chose to do it using the substitution method. Okay, let's do our final example. So a Boy Scout troop is selling Christmas trees at a local tree lot. In the morning, they sold 15 Douglas fir trees and 9 noble fir trees, earning a total of $3,021. In the afternoon, they sold 6 Douglas fir trees and 3 noble fir trees, earning a total of $1,155. How much does each type of tree cost? Okay, first we got to decide what is x and what is y. So I'm just going to make x be the Douglas fir. And I'm going to make y be the noble fir. Okay, now I'm going to go through and find the information I need for my morning equation. So in the morning, they sold 15 Douglas fir, 9 noble fir, for a total of $3,021. So that's going to be that first equation, 15x plus 9y equals 3,021. I'm going to now go find the afternoon. Afternoon, it was 6 Douglas, 3 noble, for a total of 1,155. So I am going to go ahead and make this be 6x plus 3y equals 1,155. Okay, I quickly noticed that I have coefficients all bigger than 1, so to me, this would be a perfect time to use the elimination method. I am going to write down my first equation, 15x plus 9y equals 3021. I am going to choose to multiply this second equation by 3 because I can tell I can make my y values match up pretty easily. So that's going to give me 18x plus 9y equals 3, 4, 6, 5. Okay, now that they're matching, I am going to go ahead and I am going to say, well, I want to eliminate my y value because they match. So I am going to subtract. So that's going to give me negative 3x equals negative 444. Divide by negative 3, so x is 148. So now I know that a Douglas fir costs $148. So now I'm just going to substitute into one of my two equations, so it doesn't matter which one. I'm going to do the one with the smaller numbers. So 6 times 148 plus 3y equals 1155. Okay, and this is definitely a calculator problem. Mrs. Stroll is going to go 6 times 148. Okay, so that's 888 plus 3y equals 1155. So 3y equals, I'm going to take 1155 minus the 888. I get 267, divide by 3. Y is going to equal 89, so now I know that the noble fir costs $89. And here's an example of where the elimination method, in my opinion, was the most useful for solving this problem. So now we have solved 3 different word problems using each of the methods. And again, you may choose whatever method you feel the most comfortable with, especially with the given information that you have.